I'm Steve Cole. I'm the Southern Regional Manager for Mitech New Zealand and a Fellow of the Institute of Professional Engineers. Now, in this series of What's It All About, I want to provide a clear overview of the legal requirements centred around the residential housing industry within New Zealand. I also want to cover off some of the very important documentation we use during that process. So let's get started. In New Zealand, all building works are controlled by a document called the New Zealand Building Act. Now, some of you may remember that back in 2004, the Act went through a major review, sheeting home more accountability for builders, designers, and building consent authorities. Now, of real interest to us is Part 2 of that documentation. It references a thing called the New Zealand Building Code. Now, what's really important here is that all buildings within New Zealand must comply with that code. The code does tell you how your building must perform during its intended use, but it doesn't actually tell you how to achieve that. So that's why we're here to help. Let's now have a look at the building code itself. Now, the building code is made up of several different clauses, covering off all aspects of the building process. Of particular interest to us are 3 clauses. The first one being B1, which covers off the structural adequacy of the building. In other words, we have to build ourselves a sound, safe house. The second clause is B2, and that deals with the durability of the building componentry. Now, obviously, it has to withstand the elements. It also deals with the specifics around the levels of timber treatment. It looks at the specifications around the material used in the fixings. In other words, do we need to use stainless steel or hot dip galv or so on? And finally, it is quite specific about the intended life of the building and any performance requirements around that life. The third clause is called E2, which deals with the external moisture. In other words, we are required to build a dry house. E2, for example, will give you specific details around the flashing requirements for windows, doors, and other openings. It also provides a guideline to develop what's called a risk matrix. Now, this is set up to give you requirements around wall cavities and cladding options. Let's look at the methods we use to comply with those clauses of the building code. Firstly, we have the acceptable solution. Now, in our industry, NZS 3604 is that solution. Now, that's the document that tells you how to design and build a residential structure. I'm going to cover this off in more detail later on in this segment. The verification method is the one the engineers use when dealing with designs that are not specifically covered in the acceptable solution. This pathway to compliance references 2 New Zealand standards. Firstly, we have NZS 3603, which the engineers use when designing in timber. We then have AS NZS 1170. Now, this deals with specific loads and how they are applied to the building design. The third method of compliance is called the alternative solution. Now, this is one that differs from the acceptable solution, but provides exactly the same answer. A simple example of this would be in NZS 3604, it calls up a requirement to fix a top plate to a stud using a combination of wire dogs. Now, at Mitech, we felt a more practical solution on site was to use the Lumberlock stud strap. We provided supporting evidence through testing that we achieved the correct loading capacities. So there's a quick summary of the methods we use to achieve compliance with the building code. Let's now have a look at some of the design aspects we use during that build process. I'd like now to concentrate on a document we mentioned before in the acceptable solution. It's called NZS 3604. It is quite simply the Bible for the design and construction of a residential house within New Zealand. There is enough design detail provided there to complete the structure without the need of the services of an engineer for any specific engineering design. It is broken into 17 different sections, but of real interest to us are the ones that cover off durability, bracing designs, foundation and subfloor framing, floors, walls, posts and roof framing. Even though 3604, as we said before, is an acceptable solution, there is still room in there to provide an alternative solution. Now, a classic example of this would be the roof structure. 3604 gives clear guidelines on how to complete a roof using a series of underpurlins, posts and rafters. Now, as we all know in New Zealand, the majority of the roofs are done using a trussed roof system. So there's a clear example of an alternative solution providing exactly the right answer using a different method. Finally, I want to discuss with you a term called building importance level. Now, inside AS NZS 1170, there is a requirement for us as designers to design to building importance levels. Now, they range from BIL 1, 2, 3, 4 and 5. Now, the higher the number, the greater the degree of importance of that particular building. It's all to do with that lovely term called consequence of failure. In other words, what is the risk to life, limb and property should that design fail? At the lower end of the scale, we have a BIL 1, which would typically be a farm building, a garage or a utility shed. We then move through to a BIL 2, which will be a residential structure. BIL 3 is typically a school or a public assembly area. In BIL 4, we have our emergency services or hospitals. And then BIL 5, some of the obvious examples of that would be one of the many hydro dams we have around the country. So, in summary, the building industry is governed by regulation for very good reasons, but still allows the designer to provide innovative solutions to their construction. For further information on these solutions, make sure you view the MITEC What's It All About series.